Hi everybody, we're back. This is the second problem that deals with modeling with sinusoidal functions. So this problem deals with a pendulum, and it says the following: a pendulum is swinging next to a wall. The distance from the bob of the pendulum to the wall varies in a periodic way that can be modeled by a trigonometric function. The modeling function has period 0.8 seconds. Okay. So let me just make sure. So just going to point those out. Modeling function has a period, 0.8 seconds, an amplitude of 6 seconds, and a midline as 15 centimeters. At time t equals 0.2, the bob is at the midline moving towards the wall. Okay, very important. A lot of important information right in here. Find the formula of the trigonometric function that models the distance h. The distance h, so it's the distance h, the bob and the wall that models the distance between the bob and the wall after t seconds, and define the function using radians. Okay, so let's first write this out. So some very important information, right? We have period is 0.8 seconds. Okay, the amplitude is 6 centimeters. The midline is 15 centimeters. And they're saying for this function at f of 0.2, the bob is at the midline, okay, which is 15. So at f of 0.2, the bob is at the midline, moving towards the wall, which means the distance between the bob and the wall is decreasing, okay, and it's decreasing. So the distance is decreasing, okay? There we go. All right, so the first part is what do we write this as a function? Well, definitely we have the period, so let's find the frequency. So the period is 0.8, so the frequency, right? Frequency is equal to 2 pi over 0.8, okay? Which means that it's going to be, what's 2 divided by 0.8 real quickly? Okay, so 0.8 is really 8 tenths, right? So it's 2 pi over 8 tenths, which is 0.8. But we know we can flip that, so it's 2 pi times 10 over 8, like that. So the 8 cancels with the 2, giving me 4. So it's really 10 pi over 4, which can be reduced into 5 pi over 2. Okay, and there's my frequency, 5 pi over 2. Okay, so I have my frequency. Now it looks like there's going to be a phase shift. Okay, why? Because, as you can tell, at f of 0.2, it's at the midline, and it's decreasing, correct? So if I were to draw a little figure here like that, okay, let's say this is 0 here, and this is 0.2, correct? Sorry, getting a little messy. Okay, so this is 0 here, and this is 0.2. And this is the midline right here. So this is 15. Okay, so at 0.2, at f of 0.2, we are sitting at the midline, like there. And they're saying that the distance between the wall and the bob is decreasing, correct? Right here. And it's moving towards the wall. And when you're moving towards the wall, the distance between the bob on the pendulum and the wall is decreasing, correct? So this thing is now decreasing. So it came up from here, let's say, let's say it came up from here and it's decreasing. So it's going down like that. Okay? So the question then is, since it's going down, how can we write this? All right? Okay, so we want to do this. Pretend if this was the sine function, if this was a negative sine function, okay, we know that positive sine goes like this, correct? Positive sine goes like that and then comes back down and over. That's positive sine, that's plus sine. But we know that if you throw a negative in front of the sign, okay, so if we were to put a negative sign, that would look like this. Instead of going up, from the midline, it come down to the minimum, go back up to the maximum, and finish at the midline, right? That's negative. This is almost like negative sine, except what? It started here. It started at 0.2. It didn't start at 0, which means there was a phase shift, correct? There was a phase shift of 0.2 seconds. Which way? To the right. Okay, so let's add that in. There is a shift. There was a shift of 0.2 seconds to the right, like that. Okay, so now we're going to incorporate the phase shift, and now let's write the function. So our f of t, okay, actually, yeah, let me write it, is equal to, it goes down. Okay, it goes down first, like down, right? So it's going to be a negative 6. You know what? Let me just run out of space here, so let me just make some more space. All right. So let me erase this. I'm going to start a little more to the right. So I'm going to start from here. So f of t is equal to, again, we're going down, right? So it's going to be negative, amplitude is 6 sine. Okay, and again, sorry, that's an n. There we go. And then our frequency, which is 5 pi over 2, 5 pi over 2, parentheses, and now we have our variable t, and we just said there's a shift 0.2 units to the right. So t, this is t, sorry about that, t, and then we're going to the right, so it's minus 0.2. There's our phase shift. Close up the parentheses and the brackets, and then finally your midline, plus 15. And I think we have it. I think this is going to be our function that describes this behavior. Okay, I know it's a lot, but let's type it in and see if we're correct. So negative 6 sine, and I'm going to use parentheses here, parentheses, and then we had 5 pi over 2. Okay, don't use back brackets in Khan Academy because it'll mark you wrong. For some reason, it does not like brackets. So it's 5 pi over 2, right? Let's just make sure. 5 pi over 2, good, times another set of parentheses. And we have our t, excuse me, we have our shift, minus 0.2, bracket, bracket, and then we have our midline. And I believe the midline was plus 15, right? So plus 15. Okay, and now they're asking, what is the distance from the pendulum to the wall after 0.5 seconds? Round your answer if necessary to 2 decimal places. So they want you to plug in 0.5 in here and see what the distance from the bob, the pendulum, the bob pendulum, or the pendulum, the bob of the pendulum to the wall is. So you can just plug in 0.5 here, work this out, and then see what you get. So let's use the calculator here. Make the calculator a little better so you can see it. And we'll transfer my picture over to the corner. All right, so let's type it in. We have, and we're in degrees, so let's put it on radian. They want it on radian. Okay, so we can see it. Okay, so it's going to be -6. Is there a separate negative button here? There isn't, right? So we'll just use minus. -6 sine parentheses, and we'll do 5 pi over 2. Do they have a fraction bar? Wow, this is a really, really archaic calculator, huh? So we're going to do 5 pi divided by 2. Okay, and we'll put that back in parentheses like that. Actually, okay. And now we're going to need another set of parentheses. So can I stick another set in here? I don't think so, right? I'm going to do it again. Okay. Wow, this is really, sorry. Okay, 5 pi divided by 2, close up the parentheses, and then it's going to be open up another set times our variable. Oh, that's 0.5, right? They wanted 0.5 seconds. So 0.5 minus 0.2. We could have easily just written 0.3, but we can just do the whole thing out. What is going on here? Oh, we can't see the rest of it? Oh my, how am I going to do this? So let's put 0.3 because we can't, doesn't seem like we can see it. 0.3 close the parentheses plus 15. Wow, we're working blind here, huh? Is equal to what? Okay, so I'm sorry about that. We're having a little trouble with the calculator on Khan Academy, so I just used a separate calculator, and I got an answer of 10.76. So 10.76. Okay, let's see if my answer is correct, and that is correct. Okay, so again, it's this calculator does have its limits, so I would definitely recommend that you use your calculators on your graphing calculators and make sure it's set to radian. So on this problem, what you could have done is, just to make the math a little bit easier, is let me just clear this out, right? So what you could have done here is definitely pick radian, and here just simplify it. It's 0.5 minus 0.2, which is 0.3. And then 0.3 times 5 is 1.5. So it's 1.5 pi over 2. So again, let me just see if it'll give me an answer here. So -6 sine parentheses. This is 1.5 pi, right? 1.5 times pi divided by 2. Okay, close up the parentheses, and then it's going to be plus 15. Plus 15. That, for some reason, it does not give an answer. This is very strange. Anyway, I don't know what's going on with this. Anyway, it works. Okay, so use an outside calculator. Do this. Just put 0.5 in here. Okay, and use your graphing calculator. All right, take care, guys.